Unsupervised learning, part one, mostly talking about just k-means. So in the real world, data often doesn't come with answers, right? We don't have a column that says this is a high value customer or this is a fraud transaction. We just have raw data. We need the algorithm to find the patterns for us. The most popular way to do this is clustering. And the king of clustering is k-means. So let's find out, see how it works, and try to solve a k-means iteration by hand, just like you might in like a quiz or like a test. So this is just basically what I said about clustering and k-means. Now let's look at the concept. So k-means is an iterative algorithm. That means it repeats a cycle until it finds the best answer. Here's the high-level logic. Pick pick k. You decide how many groups you want. Let's say k equals 2. So we'll place two random points on our graph, and these will be our centroids, like the center of the clusters. Then you have the loop. So phase A, which is assigned, every single data point looks at the centroid and asks, who am I closer to? It joins the team of the nearest centroid. Phase B, update. Once the teams are formed, centroid realizes it's not in the center of its team anymore. It moves to the exact average, the mean, of its new group. You keep repeating phase A and phase B until the centroids stop moving, and that's called convergence. So a hands-off example. So let's see. So the setup, we have points A, which is 1, 1, as in like x1, y1, B, 2, 1, C, 4, 3, and D, 5, 4. So we are told with centroid 1 at point A, which is 1, 1, and centroid 2 at point B, which is 2, 1. This is a classic exam setup. So if you're like taking a test or a quiz, you might see a problem similar to this, where you're given the points and the initial centroids, and you're asked to perform one iteration. So let's do phase one, assign. You need to measure the distance from every point to both centroids. Since, and by now you might know Euclidean distance, so that makes it easy. So points A and B are easy. A is at 1, 1, which is exactly where centroid 1 is. So A belongs to cluster 1. B is at 2, 1, exactly where centroid 2 is. So B belongs to cluster 2. Now for point C, which is 4, 3, we got to find the distance to centroid 1, which is 1, 1. So then, as you can see, you will use Euclidean distance to find the answer, which is 3.6. And then you find the distance to centroid 2, which is 2.8. And as you can see, since 2.8 is less than 3.6, point C is closer to centroid 2. It would join team 2. Now let's do the same. Let's check the distance to point D, which is 5, 4. Again, same thing. So centroid 1 is at 1, 1. Do the same thing. Do the same formula. You get 5. Now, for centroid 2, which is 2, 1, same thing, same formula. You get 4.2. Now, 4.2, closer than 5, so point D also closer to centroid 2. So by the end of phase 1, cluster 1 has A, 1, 1, but now cluster 2 has B, C, and D. Now, that's the end of phase 1. Let's go to phase B, or phase A. Let's go to phase B, update. So we need to move the centroids to the new center. Centroid 1 only has point A, 1, 1. The average of one point is just itself, so centroid 1 stays at 1, 1. Now centroid 2, as you can see, has B, which is 2, 1. It has C, which is 4, 3. And it has D, which is 5, 4. You have to average the X and the Y's. So here you take the averages, 2 plus 4 plus 5, divided by how many of them, which is 3. and you get 3.66. Do the same for the y, 2.66. So the new coordinates, centroid 2 coordinates, are 3.66 and 2.66. And this is one full iteration. If the exam would ask for another iteration, you would just repeat the same process using these new coordinates, 3.66 and the 2.66. Now, choosing K and common pitfalls. So, how did I know to pick two clusters? Why not three? We use the elbow method. So you run k-mean for k equals 1, k equals 2, k equals 3, and you plot the error. As you add more clusters, the error goes down. But eventually, the drop flattens out, looking like an elbow. You pick the k at the elbow. Now, outliers. K means hates outliers. If we had a point way off at like 1,000, the centroid would try to stretch all the way out there to accommodate it, ruining the nice tight clusters that we normally would have. If your data is messy, you might need to remove outliers first. So just to summarize, so K means first assign points to the closest centroid. Update the centroid to the mean. Repeat until they stop moving. But remember K means is flat. It just gives you groups. It doesn't tell you how these groups relate to each other. For that, that's something else. You need like a family tree. That is called hierarchical clustering. And that's for another topic. Thank you for watching.